Right, so we're back for a little bit more. Right, so we're going to look at cumulative distribution functions. So it's just a slight extension on what we were doing before. Just a couple of things just to highlight though, is this new bit of notation. Okay, this is, you can see this is just from your PDF file. So if you see this, this means cumulative distribution. It just means less than or equal to a particular value. Okay, and like most of what we do, looking at some examples is probably the easiest sort of idea. So let's have a look at our first example today. So what have we got? So discrete random variable that we've got here is set out, and then it's asking us to draw a table to show the cumulative distribution function for this. All right. So all it actually means here is we're going to go through our different values that we could possibly get. All right. So our different outcomes. So we got 0.1, we got 0.2, we got 0.3, we got 0.4. To be honest, those are not particularly that important within this question. Right, now, what this means, we want the cumulative function. Okay, so that basically means, the probability that x is less than or equal to the particular value that we're considering. So let's have a look. So the first one that we look at, now the first one doesn't actually make any difference because that's still going to be a quarter. The next value, so to work out the cumulative value for here, it's going to be these two together. So a quarter plus a quarter. So that's a half. I'm just going to put in here a quarter plus a quarter, okay? Just so you've got that to refer to, okay? And then the next one is plus a third. So that would be a quarter plus a quarter plus a third, which I think you'll find is 5/6. Cool. And a nice way of checking this is that when you get to the last one, what should the answer be? Okay? The answer should be 1. If it's correct, it should be 1. There you go. That's a cumulative distribution function there. Right, so let's have a look at, we've only got one more example today, and then you're going to get straight into doing some questions, okay? So not too many to do. So on this question, it's the formula below gives me a cumulative distribution function for a discrete random variable x, and it wants me to basically do what I just did, but in reverse. Now, it looks a little complicated, but actually, let's just think about, well, what do we know? Well, the first thing we want to do is work out what this k thing is. So we know, which is the important bit, all right, about a cumulative function. Well, the important bit is this one over here, because we know this. This is what this information above tells me. And if I put 4 in there, 4k, what do I know the answer to that to be? I know the answer to that is 1, because it's the last one. So it has to equal 1. Remember, the sum of all of these has got to equal 1. So therefore, k must equal a quarter. Right, now we're going to try and actually construct our probability function, okay? We can put it into a table if we want to. Alright, so how are we going to do that? Well, the easiest thing to do is to probably come back to the first one, okay? So we know that that is equal to a quarter. We know that that one is going to be 2 quarters. and we know that one. Now this one's, once you spot it, actually this one's quite a nice one, because it's actually going to produce a uniform distribution. So that's going to be 1. It's going to be, I'm going to write 4/4. Okay. So the first one's easy enough. If I want to write these down, I can put it into a table. I think that's the easiest way to see this, just so you can see exactly what's going on, right? So what are we talking about here? So we've got X probability. There we go. What are the different outcomes? 1, 2, 3, 4. So the first one is just a quarter, right? Remember, that's always going to be the same. Remember the important ones. The important ones are those two. Right. How to find the other one? Well, this one is this. Take away this. I think you'll find that's a quarter. This one is equal to this. Take away this. I think you'll find that's a quarter. And then the last one is this. Take away this, which again is a quarter. Like I said, it's a nice one because it just produces a nice uniform distribution. That's not always going to be the case. All right, so just look out for that. All right. There you go. Right, that's enough from myself today. You've got plenty of questions to go and have a go at there. Okay. Make sure remember self-mark them, and then when you've self-marked them, you can submit your work. All right. Okay. Let's see if we can manage those.